All right, guys. I'm not going to have a ton of time in class to go over monsoons. Like I mentioned yesterday, you actually only so far have only one practice test question about them, and it literally just said state what is meant by the term monsoon. But I'm just going to take time right now to go over it, and then on the back of your El Nino notes, you should have your monsoon stuff that I'm going to annotate with you on the board. So this is happening in Asia, mainly in India. So this is going to be seasonal winds that blow off the Indian Ocean towards India, and it's seasonal. So sometimes it's going to bring a really high rainy season. Other times it's going to bring a drought season. And the reason why this happens is because of unequal heating between the ocean and the land. Remember that water has a really high heat capacity, which means that it holds its temperature really well. It takes a lot of energy to move it either 1 degree Celsius or 1 degree Fahrenheit. Either move it 1 degree Celsius up or down. So take energy away or put energy in. So, in the winter, the ocean holds its temperature really well, while the land does not, and the land gets cold pretty fast. In the summer, now the ocean is not heating up super fast because it's now holding on to its lack of energy, or its lack of kinetic energy, thermal energy from the winter. But the land heats up really fast because it doesn't have a high heat capacity. It does not hold its temperature very well. Okay. So in the summer months, the land is heating up much faster than the ocean, and that causes, like, when things get hot, they rise. And so this is going to cause like this unequal temperature gradient in this like area of like empty gas, like empty air. And that makes it have a lot of low pressure. Again, low pressure because there's a lot of air pressure there. It's evaporating, moving up. So what's going to take its place is higher pressure air over the ocean. It's higher pressure because it's not going through constant evaporation, because it's holding its temperature really well. And so now that rushes in. Flip it to the winter time, the land gets really cold, so that's the high pressure area. And the water is still quite warm from over the summer. While the surface evaporates and loses its pressure, you still have high pressure now over the country of India, and the wind is now gonna leave, and you're gonna have precipitation in the ocean and then heavy drought in India. Yawning, okay. There's a couple videos that I do wanna show you. We can look at the decent monsoon video, and then we can look at the time lapse as well after. Okay, so let's do this one, and I'll kind of pause it and annotate it. This one is not on your notes. And this is a person from India talking about it.
Indian monsoon. In this module, you will understand the concept of Indian monsoon, explain the factors that determine the typicality of Indian monsoon, and also explain the role of monsoon in Indian economy. Monsoon. Indian monsoon. To the poets, it is magical. It is dramatic. In fact, it really is dramatic. Let us see what a monsoon is. Monsoon is a periodic seasonal wind that comes from sea to land in a particular season and completely reverses back with the change in the atmospheric conditions in the next season.
Look at your convergent boundary right here. It's not volcanoes, it's land-to-land convergence, so it's mountains. Same over here. Here's going to be the spreading of your new oceans. Anyways, so she just said the definition. So it's the periodic or the seasonal like wind pattern change in India caused by unequal heating over the Indian Ocean.
It is a typical yet dominant feature of the Indian climate. The term monsoon is derived from an Arabic word mausim, which means season. In olden days, the sailors found this wind convenient to set in their sails on the direction of the wind. They used to save their fuel and time by doing so. Let us discuss the causes of this seasonal reversal of wind from sea to land and land to sea. The main cause is the differential heating and cooling of land and its surrounding water bodies, that is, seas and oceans. During summer, land is hotter, and thus low pressure develops over interior parts of the large Indian landmass.
And it's low pressure because don't think that like there's no water over it, right? but there's water particles in the air. Gas particles too, like, oxygen with a lack of kinetic energy, colder air is going to sink, warmer air is going to float. And this is why we use hot air for a hot air balloon. Excuse me. Because we're making that air inside really warm compared to the air around it, and that makes it less dense and it can float. So the low pressure she's talking about, it's all of that really warm atmosphere over India is getting super hot. So hot things rise and it's going to move up. Low pressure, because it doesn't have all that gas pressure on that same area anymore, that pressure is moved up, and something's going to have to come take its place because things move from a high concentration to a low concentration, including pressure.
Simultaneously, high pressure condition develops over the seas and oceans surrounding India. Thus, a steady flow of moisture-laden wind moves towards India and causes rainfall for almost 3 months.
Okay, and so that's because things move from a high concentration to a low concentration. Air over an ocean is going to be more humid because there's water there. And so as it takes this large amounts of wind and rain and water or precipitation, moving it towards the land, that's going to help cause precipitation.
As the pressure system reverses due to apparent shifting of the sun from the Tropic of Cancer to the equator, the wind also reverses back to the same direction from where it comes.
It's like winter time now, and the sun is not really strong on the land, nor is it super strong in the ocean. It obviously is stronger southern than it is in the northern area of India. But the biggest driver of this, again, is that unequal heating and different heat densities or heat capacities. Different heat capacities, where now land can lose its temperature really fast because it's winter. Water won't. So now the land is this high pressure area. Oh, excuse me. And the water is the low pressure area because the water is warm and the surface is going to start to evaporate, leaving a lack of gas pressure there. And so something's going to have to come take its place, and it's going to be this higher pressure, colder air from India. And so that actually makes India quite arid and dry.
There is another interesting fact that the apparent movement of the sun from the Tropic of Cancer in June to the Tropic of Capricorn in December.
Okay, so it's kind of wanting you to see where it's located. I know on the map when she zoomed in, it didn't look as large as it really is, but the northern area will be cold, and then here you have your equator. I can't stop yawning. I hate that. Let's speed her up a little bit. This middle part wasn't super necessary.
Called as Southern Oscillation. Due to vast uninterrupted ocean in the southern hemisphere, the conditions are felt more than in the northern hemisphere. The normal condition brings moderate to good monsoon, whereas the reverse condition brings drought and famine to the Asian region.
Famine.
El Nino and La Nina are the two opposite ends of the Southern Oscillation or SO cycle. El Nino is the warm phase of Southern Oscillation, and La Nina is the cold phase of Southern Oscillation. These deviations from normal surface temperatures can have large-scale impacts not only on ocean processes, but also on global weather and climate. This climatic event is also known as ENSO. El means El Nino and So means Southern Oscillation. During El Nino, the monsoon will be weaker and comes late in India as summer is cooler and the surrounding sea and ocean temperature remain warmer than the usual. The Peruvian cold current is replaced by a warm current. Therefore, the pull of air from the landmass would be weak. The La Nina is good for monsoon condition as the temperature over the sea remains cooler and pressure difference between land and sea is very high. So the pulling of...
And this is, to be clear, is not El Nino and La Nina. She's comparing similarities between them, between what's happening on the Western Hemisphere versus the Eastern Hemisphere. Okay, and I don't want you thinking like things, I don't know, things move from a high pressure or a high concentration to a low concentration. And if we're comparing temperatures, warm compared to cold, cold has more density. Cold has higher pressure. warm is going to have less density and move up, and therefore it's going to have less pressure. So those pressure systems are going to move from high pressure to low pressure. So out in the sea where it's cold, you don't have that air rising. It's going to shoot it back to the land.
Of air mass from sea to land is very intense. El Nino and La Nina events occur on average every 2 to 7 years. The arrival of the monsoon rain in India is the most satisfying and joyous moment for the people of India. This is more because India is an agricultural country and the economic growth of each year depends on the amount and duration of monsoon rain. Delays and long breaks in monsoon rain are dangerous for the basic occupations such as farming, fishing and forestry. This is because chances of drought and famine increase. On the other hand, a long spell of heavy rain may damage standing crops with the increased threats of flood. The secondary sector of the economy, like the agro-based industry, also depends on monsoon, as the supply of their raw material is governed by a good spell of rain. The market will remain steady with a good monsoon year with stable price of food products, whereas a bad monsoon season will cause inflation, food insecurity and public unrest. Monsoon is a unifying bond of the nature and lifestyle of India. The rivers and ponds rejuvenate with rainwater. The soil and underground water table gets support to hold moisture and water, and the parched plant and animal kingdoms become lively with the monsoon shower. The green nature of monsoon-fed India has inspired poets and artists to create rich poetry and paintings that...
Cool. Oh, no need to go further. Okay. I'm going to close this out.
The monsoon is a seasonal rain and wind pattern that was first described over South Asia.
Okay, for this one, I want to hide the tools. Okay. I want you to look at the bottom date. So right now we're at beginning of June 2014. I want you to watch the date so we can see the different oscillations.
You see the clouds blossoming here during the summer part of the monsoon. For centuries, people have known about it, but only recently have we received enough data from satellites to really describe what's going on.
What you can see here is moist air that has evaporated from the ocean coming across India and providing rainfall driving the monsoon season. The great thing about GPM is that it allows us to see precipitating systems as a whole over land and oceans, and then as they transition from one boundary to the next.
All of this rainfall drives soil moisture over land. It's beneficial because it promotes the economic activity that people depend on, for example, agriculture. As well, it fills the rivers, which provides water for human activity and the natural environment, as well as transportation. If the rivers get too full, of course, it becomes flooding. At first, the floods you see here.
And so right now we're in July 12th. So heavy rains, and all of that is coming from the ocean, evaporation. And then it's moving over to the land because the land is so hot and all the air is risen. It has no other reason but to go towards India because it's like a vacuum, like pulling it towards it.
Here are fairly minor and broad scale, but then they concentrate in the few wiggly lines, which are the river basins, for example, in central eastern China.
In mountainous regions, when the ground becomes saturated due to heavy rains, it can lead to landslides. Landslides kill thousands of people every year and are primarily triggered by rainfall. They are especially common within the Himalayan region each monsoon season.
One really cool way to look at the monsoon is to do a split screen and look at the summer and the winter at the same time. In the summer, the wind is blowing onshore, bringing the moist, rain-laden air into the continent. In the wintertime, it blows off the continent.
Now, those winds are basically driven.
Follow your arrows, my little cursor, towards the land, away from the land. It's like avoiding it.
By temperature differences between the ocean and the land. And where the land is nice and warm, the air expands and it draws in the moist precipitation from the ocean waters. But in the wintertime, it's very cold, and you can see that the moisture then goes from the continent back into the oceans. Over the past 50 years or so, satellites have been used to measure precipitation all around our Earth. With that data set, we're able to understand that monsoons occur not only in South Asia and India, but in other parts of the world as well.
For example, Africa, where the temperature gradient is between the Atlantic Ocean and the Sahara Desert. The wind blows from the moist Atlantic Ocean onto West Africa, providing the moisture for the precipitation. Some of these westward moving storms provoke hurricanes over the Atlantic, occasionally make it to the U.S.
And if you look at the direction, I'm recording myself, I'm sorry, above the equator in the northern hemisphere, everything is deflected towards the right from the direction it's going, and everything is deflected towards the left from its original direction in the southern hemisphere.
Southwestern North America also has a summertime monsoon. You see high soil moisture in regions where there's a lot of precipitation in western Mexico, and later in the season this extends up into the southwestern U.S. And the southern hemisphere has a monsoon as well. This occurs in the northern hemisphere winter, which is the southern hemisphere summer, when Australia is warmer than the ocean to the north.
Having a better understanding of the global water cycle and monitoring changes over time is important for society, for our everyday.
Okay, awesome. I'm back. All right. Now I'm going to annotate the picture for you that you have on the back of your, sorry, this is backwards. I reversed it from being backwards, so now it's just backwards for me. But on the back of your El Nino paper, we're going to do the monsoons now. I know I mentioned that there wasn't many test questions for monsoons, but last year, 2018, they had a big one. They had a 6-point question. There's about 3 different questions going over it. Excuse me. Make sure you can see that. Okay, and I'm just going to pause it until, no, I'm not. We're good. Move it closer. Okay, cool. Vámonos. Hi.
You're finally here.
I just got a late Christmas present. Okay. All right. Let me go to the overhead. Darn it. Can you hear me? Can you hear me? Can you hear me? I didn't think this out. Okay, I can stand in front of here. I'm just going to pause it until I get my life together. Okay. I can manage this. Cool. So this is going to be the one for the summer. In the summer, it's going to be really warm. Let me get a red marker and be good. Is this a nice one? It looks nice. Yeah, that's good for me. Okay, it's going to be really warm in the summer. And we need to keep in mind that you have different types of thermal capacity or heat capacity. So I just want to give you just a little caveat down here. You see what I'm writing. Water has a high heat capacity. Land, low heat capacity. And that just means it's going to hang on to its temperature for a while. Keeps its temperature. Don't ever want to see this black marker. I made it. All right, on land, it's going to be really warm. So we're looking at India. This is going to be India right here. So we're going to have a lot of evaporation happening off the land because it has a low heat capacity. So as soon as the sun kind of comes out and warms it up, it's going to start to evaporate. You can see where I've put those little lines. And it's evaporating and moving any type of like water particles that are in the air. And let's assume that, let's say it's really arid. If gas gets warm, it's going to move up and expand. Like it's going to do that. So either way, it doesn't have to be, if I say water vapor and I'm misspeaking, that's whatever. It could just be your gas particles. That's why we have hot air in a hot air balloon, because it moves you up. Okay, now what's happening over here is this is, we're going to put HP for Harry Potter. High pressure. Just kidding. Because it's colder. That's what's causing it to have higher pressure. Same thing. Some Potter going on over here. Cool waters. Because they are still hanging on to their temperature from the winter. Even though it's summertime now and it's heating up the land. Over here, where air is rising, I'm going to put LP, low pressure. We're going to have warm land and air. Sorry, that red is a little dull. Warm land and air. Warm land and air. Rats. Okay.
Hey.
Oh, hi.
How's your weekend?
You're being recorded, just so you know.
Okay.
All right.
Are you teaching?
Yeah.
Oh, I'm sorry.
It's
Did I
okay.
interrupt your video?
I mean, it's still going.
All right. I'm so sorry.
I'm like, you're not the person to put on speakerphone. All right. This is going to cause things go from a high pressure to a low pressure area. So any type of gas and water particles over here are going to go right here to take the space of this warm air that's rising. So here we're going to annotate it. Warm air rises. That's what warm things do. Over here, cool oceanic air moves toward land to like fill in the low pressure area where the gases have left. So cool oceanic air moves toward the land to fill in the low pressure area. Now, when all of this moves over, it's going to cause it to precipitate. All of this vapor is going to start to condense, and so we're going to have high precipitation here. Notice where you're putting your precipitation. It should be precipitating on land. I'm just going to say precipitation, high precip from water vapor that was blown like from the ocean, like over the ocean. Okay. Is there a glare there? You can see. That helps. I know there's a glare from the bulb. Okay, now we're going to fill in what's happening. So I'm going to move this. Pause this if you need to finish it. Here we are. Look how technologically advanced I am. I don't know what to do about that glare. It won't matter. You can't see that. Okay, I'm going to write around it. This is the area to avoid. This is backwards. I just don't see it on here. Okay, I'm going to avoid this area. I'm avoiding it. What's happening then? So warm, moist air from the ocean is blowing to the land. We're going to say land is a higher temp in summer than the ocean. Okay. Air rises. This is because of that. And creates a low pressure LP system or environment or whatever. Warm, moist air from over the ocean comes to land, like blows over to land, blows on land. This is going to cause high precipitation and increase food yields. No famine, no drought. Okay. And 80% of the water in India is thought to come from your monsoons. There's nothing written in this. You can see this circle. It's just my area to avoid so that you can see past the glare. There's nothing in there. Okay. I may have answered it already a little bit up here, but why does the air go from the cooler oceanic water to the warmer land? So we're going to say as air increases in temperature on land, it becomes less dense and floats, or like moves up, right? Whatever. Okay, so this causes a low pressure system over land. And then you're going to have your cool, higher Harry Potter pressure moving onto land to fill in like the empty space. It's not really empty, but to fill in the low pressure area because things want to be in equilibrium. So that's why it's moving. Why does the wind move? And this is, again, because water has a high heat capacity, the land does not. Now we're going to do what happens in the winter time. It's the opposite. Okay, now this is going to be the winter time, and the opposite effect is going to happen. So the land is going to be cold. Here's India. Okay, so cooler land temps. And I literally put it right in the middle. Sorry. Cooler land temps. Put it across your land masses. And this is because, again, land has a low heat capacity. It does not hold its temperature very well. Water has a high heat capacity. It holds its temperature very well. So when it gets cold, the land's going to get cold. When it gets cold, the water is not going to get cold. The water can hold its temperature. So that one more time. So here we're going to have warmer waters. That's really light. I need a red expo marker. Oh, pink. All right. Okay. And all that says is warmer oceanic waters. Same over here. They're warmed from the summer heat and keeps its temperature. So now what's going to happen is the warm water is going to start to evaporate. And air is going to rise over the oceans. Okay, we're here too. Water is warmer. Okay, so it's going to start to rise. That's what those arrows are. The water is rising because it's still warm. Warm things rise, they're less dense. And the cooler air from the land, because it's colder, because it's wintertime, is going to rush in to fill that area. And so this is going to be your low pressure area now. LP, the low pressure, because a lot of that gas and water, the vapor that was there is now gone and moved up to the top. On land, we're going to have wind blowing towards this direction to fill in this lack of gas. Because these are high pressure areas. They're cold, particles are moving crazy, they're heavy. Okay, and what you're going to get from that, just drawing a bunch of blue arrows, we're going to have a lot of rain. Once that all that water vapor has evaporated and risen, it's going to get cooler with that cold air coming through, make it condense, and then precipitation. So it's going to rain in your oceans. Lots of rain. Okay. Just not rain happening over land. That's what this one looks like. Look at I'm evolving. I'm not in front of that circle anymore. Here's a circle. That's my face. So what's happening then? What is happening in the winter time for our monsoons? All right. We're going to have cooler air from the land blows towards the ocean because the ocean is warmer. It's going to cause heavy precipitation in the ocean. So cooler, high pressure air is blowing toward the low pressure, warmer oceans. Okay, that means there's going to be high precipitation over the oceans and not on land. Why does it go that way? So again, because hot things rise, cold things sink. Cold things are going to take the place of that warmer, lower pressure system. Why is the wind moving this way? So land, low heat capacity. Changes its temperature really fast. Water, high heat capacity. Keeps its temperature well. Okay, so the cooler temperature is going to move towards your warmer temperature, your low pressure area. Let's say the air over the ocean becomes less dense, so decreases in density and rises. Cool air blows toward it to fill in empty space. But it's not really empty, it's just low pressure. What is the result then? For land, on land you're going to have a lot of drought. This is your result. And this is seasonal. Monsoon means season. Monsoons are seasonal. So we're going to have a lot of drought in the winter. And famine. High precip over the ocean, but that doesn't really do much. Oh. The winter is, yeah, okay. Drought. So it's dry and they're hungry. The precipitation over the ocean is just really going to cause more storms, so increased storms. Okay, so that's the monsoon. Replay this, watch a different video, find some off YouTube, or the monsoon. Bye.